converting parametric equations to their Cartesian form and then working out the domain and range. Example 1. We have parametric equations that define a curve for values of t between -3 and 3. So we want to convert from parametric to Cartesian form. So if I take the equation for x and rearrange it to make t the subject, then substitute into t here in the equation y equals t squared. So now we have y equals x over 2 in brackets squared, and if we expand the brackets and simplify, y equals 1/4 x squared. So we have successfully eliminated the parameter t. This is our Cartesian equation. Now if I sketch y equals 1/4 x squared, the Cartesian form, I need to know the domain and range. So I'll go back to my parametric equations. If I make a table of values for t, and I'm using -3, 3, because these are the values at the extremes here, so we should test those, and something in the middle, 0, is a sensible one to test. We calculate x for these values of t. So for instance, when t is -3, x is 2 times -3, so -6, and y will be -3 squared, so we have 9. Then we do the same again with t equals 0 and t equals 3. Now we have to be careful here because the values which define t, they don't include the -3. It's t greater than -3, and they don't include the 3 either. T is less than 3. So the -6 and the 6 are not a part of the domain. So we can see that x is in between -6 and 6, but these are not a part of the domain. So x greater than -6, x less than 6. So these values are fine. It's only the -3 and the 3 that you have to be careful with. So if y equals 9 is not a part of the range, then the range will go from 0, 0 is fine, all the way up to, but not including, the 9. So this is our range. So you might think, why does this even matter? Why can't we just sketch y equals 1/4 x squared? I mean, after all, we have worked out the Cartesian equation. Why can't we just sketch that graph? Now here's the graph of y equals 1/4 x squared without any regard to domain or range. And we can see that on this graph I've got a y value here which is 11. I've got x coordinates greater than 6 and less than -6. In fact, this graph goes to infinity, x goes to infinity, x goes to -infinity, y goes to infinity. It doesn't stop here, the graph just continues, because I'm not taking domain and range into account. But can I have y equals 11? If I go back to the original parametric equations, my y values are between 0 and 9. Y equals 11 is not valid. There's no way you're going to get y equals 11 from this equation for these limited values of t. So when we sketch the Cartesian equation on the graph, we have to stick to the domain and range that we've worked out. So -6 to 6, like this, not including those values. The range starts from 0 all the way up to, but not including 9. This is the correct graph. This one is wrong. Example 2. We have two parametric equations. T is greater than -2, so -2 is not included for the parameter. I'm going to convert this to its Cartesian form, and then we're going to work out domain and range. So starting with the equation for x, if I do e to the power of on each side, because I want to eliminate the natural log, the e and the ln cancel, function inverse, they will cancel, leaving t plus 3. Rearrange to make t the subject, so t equals e to the x minus 3. Now I can substitute this into the equation for y here, like so, and then simplifying. So we're looking for domain and range, so I'm going to make a table, and sensible values to use for t include -2, and t is greater than -2, so 0 would be a sensible value, and because there's no restriction for the upper value of t, an infinitely large value would be sensible too. So when t equals -2, we need to put that in here for the equation for x and here for the equation for y. So for x we have ln -2 plus 3, so ln 1, which simplifies to 0, and for y is equal to 1 over -2 plus 6, so we have a quarter. But again, remember, -2 is not a value that t can take. T is greater than -2, so we have to be careful with these values when we consider domain and range. They may not be a part of our domain and range. Okay, now using t equals 0, you put 0 in there, we've got ln 3, approximately 1.1, and if we put 0 in here, we've got y is equal to 1/6. Now if t is a very large value, an infinitely large value, for x we have x is equal to ln, an extremely large value, an infinitely large value, plus 3. Infinity plus 3 we can simplify back to this. Infinity plus 3 is infinity, and then the log of an infinitely large value will be an infinitely large value, so x approaches infinity. Okay, we do the same for the y equation, so y is equal to 1 over t, which is an infinitely large value, plus 6, which we can simplify to 1 over, because infinity plus 6 will just give you another infinitely large value, and y is equal to 1 over infinity. It means y is approaching 0. You can try this on your calculator. If you do 1 divided by a very large number, you'll see that you either get something very close to 0 or perhaps 0 as well. So for the domain and range, now domain, we start from 0, we go to 1.1, we're going towards infinity, but 0 was not included because -2 was not a part of the value that t is allowed to be here, so x greater than 0. Now for the range, we have y equals a quarter, 1/6, so the y values are getting smaller even though a quarter is not included. Yeah, we can't have a quarter for the same reason as before, because it comes from t equals -2, and t equals -2 is not valid. We've got t greater than -2. So we start from a quarter but not including it. We're getting values which are getting smaller, and they're approaching 0, but not equal to 0 either. So our range is between 0 and a quarter. So y greater than 0, less than a quarter. For practice, try these questions.